So I gave the same talk in New York 2 years ago at Strata, and initially I just wanted to use the same slides and talk about the same things, but I kind of realized that things have changed in the last 2 years. Actually, not necessarily dramatically, but I think what changed is the concepts of a data lake and the concepts of big data and machine learning has gotten a little bit more refined, and people understand it a little bit better. And to prove you that, I'm going to just ask you, who knows what a data lake is? Come on, don't be shy. All right, so that's about, let's say, 40%. So in New York, at Strata, it was like 20% last year. So people do get it, right? So they learn about things. And as Lucas said, being a little bit later to the game, as Romania is versus the US, gives us a unique opportunity of using more mature concepts and more mature tools and technologies that we can work with. So now we sort of can get in faster and without the pain of all those arrows in our backs. Right? So this talk is going to be about how to build data lakes in the cloud. Right? And we're also going to talk about what a data lake is and why you should do it in the cloud or on-premise. But before I do that, this is me. And of course, I'm Director of Product and Development of Bigstep, and I'm technical. So if there's something that you don't understand in my talk, do raise your hand and ask me questions. There's going to be a little bit of time afterwards, but I hate giving these sort of TED Talks, right? So I like that. So just stop me at any time. I don't know if you've heard about Bigstep. If this is the first time you interact with us, you've heard about us. We're a cloud company. We're a cloud company specialized in big data. And we basically give people the tools, technologies, and infrastructure, and more recently, the knowledge that they need to bootstrap big data initiatives in their organizations. And we're still a startup. Right, so we're going to talk about what the data lake is, why in the cloud, right? How does a typical data lake stack, from a technical perspective, look like? Because I know, at least from the workshop that I gave yesterday, that there's a lot of technical people in the audience. Am I right? So who considers themselves technical? All right, so that's like 80%. Okay, so how do you push data to the cloud, and how about GDPR? So for the rest of you, right, the remaining 20%, GDPR is going to be really important. So I had to talk a little bit about that at the end. So timing. We're not going to spend that much time here, but just a few more recent studies done on whether it makes sense to do big data or not, or it makes sense to become data-driven or not. Right? And the first study is from 2018, and they looked at like 800 companies trying to see what the impact, the actual impact is on the bottom line and productivity, and it looks like it's 3.7%. Can you see it in the back? Okay, good. So 3.5% productivity increase, 6% profit increase, or 9% over 5 years. But it really, what the study also says is that there's a big difference in the industry in which you are. So certain industries have a better chance of leveraging data than others. And it looks like the more competitive industries are more better positioned to make use of this, right? And versus others. But at the same time, this also means that there's a lot of companies that get left behind into this getting data-driven thing, and there are such a thing as data native companies and non-data native companies. And data native companies, the Facebooks, the Googles, the Apples of the world, they know intrinsically how to build things from scratch, how to run experiments, how to make quick decisions based on the results of those experiments, and they basically are on the offense all the time. And this also means that from the big Fortune 500 companies of the world in 1955 until now, the average lifetime of a company has shrunk a lot. And the reason for that is because all the incumbent companies have a hard time being on the offense and becoming data-driven, even though they know this is a good thing to do. They just have a hard time. They just don't have the mentality. They spend so much time working with consultants before making a decision whether to invest in this or that. Not in big data, but in general, that they just, they don't move fast enough. And so the idea is embracing this concept of becoming data-driven has become a lot more important nowadays if you want to survive. And no matter how big you are, chances are, you might go down if you don't, act. If you only play defense, then you're gonna waste a lot of time. Okay, so let's get to the point. So, big data versus BI, business intelligence. So I still get a lot of questions from people, what is big data? And I'm not gonna answer, with the 3 V's and such. You guys are technical, you all know it. But if somebody asks you, how do you describe big data, try to do a comparison with something that they know. And people know business intelligence. They've been doing it for some time, especially in the business field. And I think fundamentally from the 2 distinct categories, business intelligence uses descriptive statistics, which means you look at the tables and you see, you do sums and totals, and you describe the reality in a very exact way. And that's one way of doing things, and you extract knowledge from that type of statistic and graphs. Whereas using data typically means building models of the world and using something that's called inductive or inferential statistics. And this means that you look at a population of things and you try to understand what happens in reality for the entire set of customers that you might have. So you use that for prediction, and building models is then essential to big data. And what does a model mean? So, well, essentially it means that you have basically a customer simulator or a process simulator, a robot next to you that you can ask things like, is this new type of product that I want to launch going to be successful or not? And you can answer that question, yes, it's going to be, or not, it's not going to be, like my friend from Futurama is. So modeling, I think, is essential, and I think it's a fundamental distinction between everything that we've been doing until now and big data. Now, a data lake, and things get a lot murkier if you go into the weeds and stuff, and the data lake is one of those concepts that floats around big data and cloud and advanced analytics and nowadays artificial intelligence. And what's important is to understand where it fits. It basically is that storage layer, right, in a big data stack. And it's not enough to do things, right? So you just deploying data lake is not enough to get advanced analytics, but together with other tools, it does allow you to do that. So fundamentally, the question is what a data lake is. It is that storage that you need where you bring data from all different sources and you aggregate those data into a single source of truth. And why do you do that? And what's the difference between a data warehouse that you guys might have heard of and has been used as a concept before? Well, the difference is that you use it to store data in a different way, fundamentally different way. And that way is called, doing schema on write or schema on read. Keep storing data that's structured versus unstructured or semi-structured. And you guys are developers, you know what JSON and XML is. And storing the XML in the original format preserves a lot more knowledge that you might not use in that particular time, but you might use after a while. So it helps you get a little bit more information out of the data that you store. And it's also a lot more affordable. So it's a trend nowadays to keep all the data that you accumulate and to potentially use it differently later on. And because you gain data from all these different sources, of course, different sources have different data formats. So instead of trying to fit everything into a fixed schema like this, so say you have an ID card or a series of ID cards. This is just a demonstration. And what you can do with, let's say, schema on write is get the information on the on the ID card and try to fit it into and to fill all the little fields in a table that you've defined from the get-go, right? That has age, name, surname, and address. And this is one way of doing things. This is the way you do it with traditional databases, data warehouses, and all that stuff. But with schema-on-read, what you do is basically store, let's say, the raw ID card, and when you need to use and when you need to access those fields, then you extract the data from the cards and just use those data. But there is data in the ID card that you have not thought about or utilizing in the beginning, say maybe the security elements of it or the picture. So you extract that only when you need it. So basically that's the difference between schema-on-write and schema-on-read, and that's the difference between using a data warehouse and a data lake. Is that clear? I know it's superfluous for a lot of people. A lot of you have heard this before, and I'm sorry. But I think it's fundamental to go over these parts. Okay, so why in the cloud? A lot of you have built things on premise, and 2 years ago, when I thought about data lake in the cloud, people were like, "No way, man! It's very hard for me. I'm a bank. I do things with critical data. I couldn't possibly trust it to the cloud." But 2 years after, this is no longer such a critical, far-fetched idea. We hear banks talking about the cloud. We hear a lot of companies ditching their existing infrastructure and moving into the cloud. Not just IT-centric, IT-focused companies, but also more traditional companies. So yeah, it makes sense to build a data lake in the cloud. And even though, and cost is not the primary reason, there are other reasons as well. And fundamentally, I think the reason is the lack of expertise for people to run complex infrastructures. And you're going to see the architectures later on-premise. It's a lot easier to just buy certain services from the cloud. And even if you build it in the cloud, with your expertise in a sort of self-service mode, it is still easier to scale and to just scale with the data that you put in rather than just over-provision everything. Right. So there are 3 types of, let's say, uses of big data in the cloud. It's a self-managed, fully managed, and as-a-service kind of uses. Self-managed is when your IT staff just buys machines in Amazon or Google or Pixel or what have you, and just starts deploying Hadoop and doing all that stuff and maintaining it themselves. Fully managed is when you ask somebody else to manage it for you, but basically you just use the machines again directly, you roll compute power. As a service, very different. You buy things like Amazon S3, right? And you use that with maybe Aurora, or you use it with Snowflake, or various bits and pieces of services that you couple together and you build your data lake. Or your data, let's say the data laboratory that you make the data lake central of. Okay, so technologies. So I'm going to ask you, who has heard of Apache Drill? Okay, so it's like 5%, 10%. Who has heard of Impala? Okay, 30%. Okay, Datamir? Like 5%, 10%. All right, so the idea in general, when you build a data lake, if you do it this way, let's say a more traditional way, is that you need a storage layer and you need a compute layer. And most of the times these two things are separate from each other. They are separate logically in the sense that even though they really say reside on the same physical machines, there are different pieces of technologies handling the underlying processes. And one of the file formats that you typically use